Hi class, we are going to do a review of speed because I think I covered this topic through a flip chart when I was out. So I wanted to make sure that those of you that needed a little bit more assistance are able to get some extra help for this topic. So to start off, just remember that position, we usually will call position S sub t. Sometimes you'll see me call it x of t if it's horizontal motion, and other times y of t if it's vertical motion. Velocity is v of t, and that is the derivative of position. And we can write it with the prime, or we can write ds dt. And remember, we like to use this method right here because it actually tells us our units. So the units of velocity will always be the units of distance divided by the units for time. So these notes are actually coming out of the 3.4 notes packet that we had. And so if you get that out, you will be able to follow along. We talked about position, we talked about velocity, and I want to make sure that you know that acceleration is the derivative of velocity. And velocity is move that out of the way, second derivative of, acceleration is the second derivative of position. So a of t is equal to the first derivative of velocity or the second derivative of position. And remember that the other way of saying velocity's derivative would be dv dt. So acceleration units are always the velocity units divided by the time units. Speed is the absolute value of velocity. In terms of a concept, it's how fast an object is moving. And which way we move does not matter. So if we wanted to talk about moving forward and moving backwards, that actually has to be velocity. Velocity tells us which way we move. Speed just tells us how fast we are going. So graphically, speed is literally the absolute value of velocity. So I'm going to do the graph of speed first. Actually, maybe I'll do that at the end. I actually want to talk about speeding up and slowing down using a velocity function. So in speeding up and slowing down, given velocity, speeding up means that the absolute value of your velocity is getting bigger and bigger and bigger. Now, the best way for me to describe that graphically is to say that the graph goes away from the x-axis. So let's take a look. If you look at the graph down here, we're starting at a velocity of 1, and we don't have units, so we'll just call it 1. And now we're at a velocity of 2. So we did get to go faster. Now, from a velocity of 2, we are now in red at a velocity of 0. We are slowing down at that point. Now, here's the part that's very confusing. This red portion here, the velocity goes from 0 to -4, but our speed goes from 0 to +4. So if you look at the graph, and if I trace the velocity graph, I'm actually moving away from the x-axis. I do it there, and I do it from 1 to 2. And I am going to call this seconds, so I have a way to reference the x-axis. Another time that I move away from the x-axis would be from 9 to 10 seconds. Those are the times that you're actually speeding up because you're moving away from the x-axis. That actually means that your speed values are getting bigger. your velocity values may not be. And what I mean by that is if you look at this pink section, my velocity values are decreasing, but you're actually speeding up. The speed itself is increasing because you went from a speed of 0 now to a speed of positive 4. Now slowing down, we're going to talk about in terms of going towards the x-axis. So, given the velocity graph, your graph goes towards x-axis. And so going towards the x-axis, that would happen from 2 to 3 seconds, and once more from 5 to 9 seconds. And let's look at the speed values. The speed's at 2 here, and then going towards a speed of 0. So we are definitely slowing down. In this portion right here, the speed is positive 4, and we're going towards a speed of 0. And so you can see that the speed values are decreasing. So we actually would be able to answer the questions to the right here. But before doing that, in case that's kind of confusing for you, I want to show you one other way. For some of you, it may just be easier to graph the speed. And so what we do to graph the speed is I'm going to highlight all the pieces of the graph that are negative. That's the yellow portion here. And the way that you graph speed is you will literally reflect across the x-axis. So this point, I'm actually going to graph the point so it's a little bit easier for me to graph. And my zeros are here. I'm going to connect those lines. And the graph of speed will now look like in red. This portion, we go down to here, go up to this point, go down to the 0, and go back up. So you literally are not looking at any portion of the graph that's underneath the x-axis. And so I'm literally going to highlight in yellow the portion of the graph we're looking at. That's only this piece. Okay. So we're going to answer these questions one more time, because I didn't write down the answers the first time in case it was a little confusing. We're only going to look at the piece that's yellow. So in answering speeding up, that means your speed is increasing. And where is my speed increasing? It's wherever my slopes are positive. So in red, this portion here from 0 to 2 seconds, and again from 3 to 5 seconds, and again from 9 to 10 seconds. In blue, and I'll close that bracket. In blue, we'll do slowing down. That's where my speed decreases. Slowing down is from 2 to 3 seconds, from 5 until 9 seconds. If you rewind and go back to when we were talking about speeding up and slowing down the other way, you'll notice that the answers match exactly. If you're looking at the velocity graph, you want to use the hints I gave you up here. If you decide to graph the speed, then you're really looking at if the speed graph increases and decreases. You do not look at the velocity graph anymore, so we don't care if it goes towards or away from the x-axis. That actually will still work, but I like using the words increasing. If you look at speed, speed will increase when you move away from the x-axis. So that's here and here. Speed will decrease when we go towards the x-axis. And so the definition I gave you up top with velocity really does work for speed, okay, going towards and away from the x-axis. Your maximum speed happens to be a speed of 4, no units because I didn't give you velocity units, and that's because the speed graph shows the max here. Now, when does it occur? It occurs at 5 seconds. The speed is actually 4, though. So you really want to look at maximum speed. You're looking at the absolute value of velocity, because on the velocity graph, that point was the minimum. It's now become the maximum because of the reflection. And we're going to look at algebraically what speed is. So algebraically, you will need the velocity and acceleration. So even though the question is asking about speed, oddly, you have to use two functions to describe speed algebraically. Graphically, we really only needed the velocity. Algebraically, you need velocity and acceleration. So if you are speeding up, the easiest way for me to describe this is that velocity and acceleration have the same sign. Slowing down, your velocity and acceleration have different signs. And what do I mean by same and different? We'll write them here. On top, your velocity can be positive. That means your acceleration must be positive. If your velocity is negative, then your acceleration must be negative. For slowing down, if your velocity is positive, then your acceleration must be negative. And if your velocity is negative, your acceleration has to be positive. Y of t. So now we're going to look at an actual algebraic problem here.